Swayam Prabha. Digital India. Educated India.
Now, let us apply the concepts we learnt about initial notation, vector algebra and transformation of vectors to solve some problems. First example that I am going to consider is the following. Example 1, this combines the concepts of Kronecker delta with the initial notation. Say I want to find the value of delta I. You know that delta I is 1 phi equal to j and 0 phi is not equal to j, and you know that if an index is repeated twice on the same side of the equal to sign, it is sum it from 1 to 3. So, delta I would be delta 1 1 plus delta 2 2 plus delta 3 3, and from this equation in here, you know that each of this will take a value of 1 and hence it is 1 plus 1 plus 1 is equal to 3. So, the value of delta I is 3. Okay. In example 2, let us say I have an equation of the form, I want to find what is the value of B I, so written as delta I j a j. Okay. I have the equation B I equal to delta I j a j. So, what is B I is a question here now. Okay. Now, again I know if index is repeated twice on the same side of the equal to sign, which is the j here, sum it from 1 to 3, hence this will imply that B I is nothing but delta I 1 a 1 plus delta I 2 a 2 plus delta I 3 a 3. Okay. Now, if I substitute I equal to 1, if I equal to 1, B 1 would be delta 1 1 a 1 plus delta 1 2 a 2 plus delta 1 3 a 3. This will mean that delta 1 2 is 0 because of the fact that delta I is not equal to j, then delta is 0 and hence this will be 0 and this will also be 0, hence this will be a 1. So, from solving this equation, similarly if I equal to 2, B 2 would be a 2, and if I equal to 3, B 3 be equal to a 3. All this implies that B I be nothing but A I's. Okay. This is the second example that we have seen, where we use both the concept of Kronecker delta and the initial notation, that if an index repeats itself twice on the same side of the equal to sign, sum from 1 to 3. Okay. Moving on to the example 3, let us say I have A B given by epsilon A B C A C or B C. Okay. Now, what happens? Epsilon is a permutation symbol. You know that epsilon I j k would be such that it is 0 phi equal to j or any of the index repeats itself, j equal to k or k is equal to I, and it will be 1 for a cyclic permutation of I j k and minus 1 for a non cyclic permutation of I j k. If the permutation is like this is going to be minus 1. Okay. So, now what is this? What will be A 1 1? A 1 1 would be epsilon 1 1 C B C, 1 1 repeat itself. So, this will be all 0 irrespective of what C value is. Okay. Similarly, A 1 2 would be epsilon 1 2 C B C. C is a repeated index, so I have to sum 1 2 3. So, it will be 1 2 1 B 1 plus epsilon 1 2 2 B 2 plus epsilon 1 2 3 B 3. Here again 1 is repeated, here again 2 is repeated. So, both of these are going to be 0 and 1 2 3 is a cyclic permutation. So, this is going to be B 3. Okay. Similarly, A 1 3 is going to be epsilon 1 3 1 B 1 plus epsilon 1 3 2 B 2 plus epsilon 1 3 3 B 3. Since 1 is repeated here, this is going to be 0, 3 is repeated here, this is 0, 1 3 2 1, 5 is 1, 5 is 1, 2 and 3, it goes like this 1 3 2, right. So, this is a anticlockwise permutation. So, this will take a value of minus 1 and then this is minus B 2. Okay. Similarly, I can show that A 2 1 is going to be minus B 3, since this will be nothing but A 2 1 1 B 1 plus epsilon 2 1 2 B 2 plus epsilon 2 1 3 B 3. Okay. These two are 0 again, because an index repeats itself. Here 2 1 3 is again going in this fashion. Here again 2 1 3 is going in this fashion. It is in the anticlockwise permutation and hence it is minus 1, hence this will be minus B 3. Okay. Similarly, A 2 2, just like A 1 1, it repeats itself twice. C B C, this is going to be 0. A 2 3 is going to be epsilon 1 2 3 1 B 1 plus epsilon 2 3 2 B 2 plus epsilon 2 3 3 B 3. 2 3 1 is again 2 3 1 is again have this. If I is 1, j is 2 and k is 3, 2 3 1 is in a cyclic permutation, 2 3 1 is in a cyclic permutation, 2 3 1 is in a cyclic permutation and hence this will be nothing but B 1. Okay. So, similarly, I can find the remaining components of A B, namely A 3 1, A 3 2 and A 3 3. Okay. Then I can write the matrix A as, this matrix A would be A B matrix would be 0 B 3 minus B 2 minus B 3 0 B 1 B 2 minus B 1 and 0. Okay. So, this will be the matrix A B, it will be a skew matrix. Okay. Now, moving on to another example, example 4. Now, let us say I have two vectors, A given by 12 Ex plus 4 Ey plus 3 Ez and vector B given by 5 Ex plus 6 Ey plus Ez. Now, I am interested in finding A dot with B, the dot product of A and B. How do you find this? Now, I have to multiply, scalar multiply 12 Ex plus 4 Ey plus 3 Ez dotted with 5 Ex plus 6 Ey plus easy. Now, this will be 12 into 5 is 60, Ex into Ex, Ex, Ey, Ez are orthonormal bases. So, dot product with itself will be 1, dot product of Ey dot Ex or Ez dot Ex will be 0. So, this will be 60 when I take this 5 and multiply with this 12, and then it will be 4 into 5 20 into 0, 3 into 5 15 into 0. So, those do not contribute, and then plus 6 into 12 72 into Ey dot Ex will be 0 again, whereas 4 into 6 24, 4 into 6 24, Ey into Ey will contribute because that is 1, and Ez dot with Ey is 0 again. So, that is not going to contribute. Then Ez similarly only the 3 will contribute, so it will be 3 into 1, which is nothing but 60 plus 24 plus 3, which will be 87. Okay. Now, I want to find what is the angle between A and B vectors. Say A vector was some can be represented by some dotted line segment like this, and B vector is some vector represented like that. I want to find the angle between A and B vector theta. How do you go about doing that? You will go about doing that by recalling what a dot product is. Then you will recall that cos theta is nothing but A dot with B divided by magnitude of A times magnitude of B. Okay. Just now we found what A dot with B is. Now, we have to find the magnitude of A. Magnitude of A is going to be A dot with A itself, and take a square root of that. Okay. From the same principle that what we followed for A dotted with B, A dotted with A would be square root of 12 dotted 12 multiplied by 12 itself, because other components are going to be 0, plus 4 multiplied by 4 itself, plus 3 multiplied by 3 itself. So, this will be root of 144 plus 16 plus 9, which will be root of 169, that is nothing but 13. Similarly, magnitude of B is going to be square root of B dot with B, which will be square root of 5 square plus 6 square plus 1, that is square root of 25 plus 36 plus 1, which will be 7.87. Okay. So, now cos theta is A dot with B is 87 divided by 13 is magnitude of A, magnitude of B is into 7.87. Okay. So, if I do this, this will imply that theta is 31.8 degrees. Okay. Now, here luckily the numerator was positive. So, there was no confusion on how to resolve the theta. Otherwise, you have to make sure that the cos theta negative thing is taken care of appropriately. Okay. The sign matters, otherwise the theta will lie between 0 to 90 or 90 to 180. Okay. So, depending upon the sign of the numerator. Okay. Next, I am interested in finding the area of the parallelogram. Next, I am interested in finding the area of the parallelogram with the previously mentioned vectors A and B as its side. Okay. So, basically I have vector A and B, I want to find the area of the parallelogram. So, what should I do? Area of the parallelogram is given by area of parallelogram given by the magnitude of A cross B vector. Okay. You know that A was 12 E x plus 4 E y plus 3 E z cross product with 5 E x plus 6 E y plus E z, and I will take the magnitude of this resulting vector. Okay. I can use the permutation symbol and I can recognize that E x cross E x is 0. I can use this fact that E x cross E x is 0, E x cross E y is E z, E x cross E z is minus E y, okay, and I can use the fact that E y cross E x, the negative of this is minus E z, E y cross E y is 0, E y cross E z is E x, and E z cross E x is E y, E z cross E y is minus E x, and E z cross E z is 0. I can use these facts to resolve this cross product, but there is another way of doing this which you would have learned even in high school, wherein you write E x, E y, E z and take a determinant of this matrix, right. That is okay because it yields the same result. So, this will be E x into 4 minus 3 into 6 minus E y into 1 into 12 minus 3 into 5 plus E z into 12 into 6 minus 4 into 5, right. Okay. So, this will be minus 18 plus 4 would be minus 14 E x plus 12 minus 15 is minus 3, minus becomes plus 3 E y, and then I have 72 minus 20. So, that will be 52 E z. Okay. This is the area, oriented area of the parallelogram with sides A and B as its sides. Okay. So, now what will be the magnitude of this? Magnitude of this is going to be square root of 14 squared plus 3 squared plus 52 squared, which will evaluate to be 53.93. Okay. This is how you find the area of the parallelogram. Next example that I want to do is example 6. Find a unit vector C which is perpendicular to to A and B. You know that if I take a cross product, the resulting vector would be orthogonal to the plane containing the vectors A and B, right. So, I want a unit vector of that. So, how will I get that? I will get that as A cross B divided by norm of A cross B. A cross B gives a vector which is perpendicular to A and B, and norm or magnitude of that vector makes this a unit vector. Okay. So, we saw in the previous example that A cross B is given by that expression. So, this will be nothing but minus 14 E x plus 3 E y plus 52 E z divided by 53.93, which will be minus 0.26 E x plus 0.05 E y plus 0.95 E z. Okay. Finally, in vector algebra, I want to find the volume of the parallelepiped with sides A, comma B, comma C, what we found here as C. Okay. So, that is I have A like this, B like this, say C is normal to this. So, C is a vector like that. Okay. So, I am interested in finding the volume of the parallelepiped So, C is perpendicular to this. So, I am interested in finding this is C, wherein I will have projections coming out like that. Okay. I am interested in finding the volume of this three-dimensional object. Okay. So, how do I go about finding that? Volume is given by the box product of A comma B comma C, which is nothing but A cross B dotted with C. Okay. So, this I can write it in a matrix form as minus 0.26, 0.05, 0.95, 12, 4, 3, 5, 6, 1. Okay. So, basically A cross B is this A cross B dotted with C, instead of E x, E y, E z, you write the components of C there. Okay. And you have to do the same determinant operation here to get the components of get the scalar value of the volume of the parallelepiped. Okay. I will use this as an exercise for you to do. Okay. Finally, let us look at an example problem on transformations. Example 8. Say I have transformed, say you have coordinate system E x, E y, and this coordinate system was rotated to E x tilde and E y tilde, such that E x tilde is given by 0.6 E x plus 0.8 E y and E y tilde is given by minus 0.8 E x plus 0.6 E y and E z tilde remains as E z. Then I am interested in finding how this vector u given as 3 x plus 4 y plus 5 z will transform. I am interested in transforming this vector into some component of x tilde plus some component of y tilde plus some component of z tilde. Okay. For this, first you have to find the transformation matrix Qij, which is given by Qij, which is defined as E I dotted with E j star or E j tilde. Okay. Now, this will be nothing but E 1 dotted with E 1 tilde, E 1 dotted with E 2 tilde, E 1 dotted with E 3 tilde, E 2 dotted with E 1 tilde, E 2 dotted with E 2 tilde, E 2 dotted with E 3 tilde, E 3 dotted with E 1 tilde, E 3 dotted with E 2 tilde, E 3 dotted with E 3 tilde. Okay. So, this will be nothing but, I know that E x star is nothing but, I know that E x star is E 1, E y star is E 2, I can substitute for x and y 1 and 2. So, if I do this operation E 1 tilde dotted with E 1, I will get it as 0.6, this will be 0.6, this will be 0.6, this will be 0.6, E 2 dotted with E 1 is this, E 2 dotted with E 1 is this dotted with E 1, this will be minus 0.8, minus 0.8, this will be 0. Similarly, this will be 0.8 because it is E 1 tilde dotted with E 2, E 1 tilde dotted with E 2 is 0.8, that will be 0.8, this will be 0.6, 0, 0, 0, 1. That will be your transformation matrix. Now, you know that U star, the components in U tilde, components in U tilde is related as Q transpose times U. So, this will be 0.6 minus 0.8, 0, 0.8, 0.6, 0, 0, 0, 1 multiplied by the components in U, which is 3, 4 and 5. So, this will be nothing but 0.6 into 3 plus 0.8 into 4 minus 0.8 into 3 plus 0.6 into 4, and this is going to be 5. Okay. So, this is nothing but 0.6 into 3 is 1.8 plus 3.2, this is going to be 0 and this is going to be 5. Okay. That is going to result in 5, 0, 5 as the transformed coordinates of this vector into the transformation shown here for a transformation given there. Okay.